the weekend so that you can watch how I do these questions, okay? It's the same technique over and over and over. You just got to pick up the pattern, okay? Fit. All right, here we go. Conditional probability. I want you to copy down this formula here. Which, once it comes out, there we go. I want you to copy this formula down, and I'm going to describe what this means in the theory, okay? So today's part is only 15 minutes long. I just want to get you the theory across, and then we do one example so you can see realistically what this is trying to say. Okay? So, what's conditional probability? It's when you have a condition, okay? But this is where a lot of students get confused by. It says probability of an event A. Event is the first thing that happens, occurring when it is known that something else has happened before that. Okay? Is called conditional probability because there's a condition behind that. Okay, so what's an example of this? Something like if you think about it logically, I can say
on the weekend and go to the football.
Thank you. If you think about it, if I told you every day I walk on this particular path, okay, and the first day I walk to school, I trip on this rock in this particular spot. Okay, my chances of tripping is like 1 over a million. Okay, but let's say that was my chances, and I tripped over it. That was one time. Now, what's the chances logically? What's the chances if the second day I walk, what's the chance of me tripping on the exact same spot again? Is it higher, lower, or the same?
Way lower.
Way lower. Because what you just said there was logical.
It's like being struck by lightning twice.
Yes, exactly. Because the chances of it happening again through experience, because the second time I walk by, I'm like, oh, yesterday I tripped over here. I'm likely to avoid it. It's not like I'm going to go, oh, trip. All right, tomorrow. Oh, trip. Oh, tomorrow. Oh, trip. Then that would mean that the probability is consistent. That means I don't learn from a mistake. That's very bad. So logically, what's the condition in my case here? Let's tie things together. Conditional probability is what I just explained in, thank you, Trent. What I just explained was the chances of me tripping, given that I had tripped before. That's what the condition is. So the condition is given that, Lauren. The condition is, what if I tripped before already? So given that I tripped before, what's the chance of me tripping again? That event A is likely that it's going to be unlikely for me to happen. Because it's going to be lower. The chance it has to be lower because of this event. If I didn't trip over it beforehand, it won't lower anything. The chance of me tripping is 1 out of a million. But as soon as I say that I've tripped over it before, the chance of it happening again is much lower. Okay? So that's what this is trying to say. Now, how do you say, given a condition, this vertical line here means given. So what it's trying to say is probability means chances of me tripping, okay, chance of me tripping, given that I tripped already. So the condition could be anything. It could be given that I was sick, given that I was not happy that day, okay? So chance of me tripping, given, and there's a condition to it. So that's why we call it conditional probability, because the vertical line means given, B means what has happened beforehand that affects. It's all about affecting. Okay, my chance of tripping depends on what happened before, and that's a key word there. Depends on. The chances of something happening depends on the one before. That's what condition is. The condition is depends on what happened before. Okay. Whereas you find the last exercise is called independent, which means it doesn't matter. So independent events, if you're interested in the last exercise of 9G, it just means that every day I'm going to trip over it the same way. I don't learn, it's independent. Doesn't matter if I was sick, doesn't matter if I was happy, doesn't matter if I tripped over it beforehand. The chance of me tripping is always the same. Okay, that's independent. Okay, now, what's the rule saying? So they're saying, how do you find out the conditional probability? That's the conditional probability here. How do you find it? This is the chances of me tripping the second time and tripping the first time. What's happening? What's the chance of them both happening at the same time? So yesterday I tripped. What's the chance of me tripping again? So that's 2 of them happening at the same time. Over the chances of me already tripping it. Because I've already happened. Now this is where it gets confusing because you're like, what do you mean? That's already happened. What's the chance of it already happening? I'm going to show you in another example, that last chart, just to leave you thinking about it. Friday, 2 more examples, and you see it's the same drill over and over. The most confusing part for a lot of students is not finding this, it's finding that, because these two almost sound the same, and they're not. See, the reason why a lot of students confuse these two is because this is sort of saying chances of me tripping and tripping before. This one means chances of tripping given that I already tripped. Okay, those two are very different, but a lot of students will mix these two, and that's the hard part to solve, all the way to year 12. That's one of the hardest ones to do. Okay? Yes, Finn?
So is B on like a tree line, like A and B?
Very good. Okay. I'm actually, what Finn just asked there is a very good question, and maybe I'll just tie it up there. On a tree diagram, you're going to be using tree diagrams for this exercise a lot. And remember when we flip a coin, you said H, tails, H, tails, H, tails. And you said to me that to find the chances of getting H and then tail, we said it was H and T. And this is what you would have wrote. You would have wrote this. You would have said chances of getting H and T, and you would have done half times a half is a quarter. True? Now, the only difference in conditional is exactly the same thing. There is no difference. It's the difference in interpretation. Guys, you can talk about this later. Yeah, it's only about 5 minutes left. Now, the difference between what Finn just asked, this is H and T. It's true. You are right. You're not wrong. It is chances of this first occurring and then chances of this occurring. Now, the reason why in conditional it is slightly different is only because of the interpretation of the situation. Here, chances of getting H is half. The chance of getting tails doesn't matter if you got heads before. It doesn't matter. This chance of getting tails does not depend on H. True? Every time you flip a coin, it doesn't matter how many heads you get before or tails before you get head. It's always the same.
So it's not conditional.
But yeah, but when it's conditional, this is still the same. But the only difference here is right this. It will say chance of getting tails given that you got H beforehand. That's the difference between the two. But calculating it is exactly the same. It would be H times that. That's the chances of getting H and T. Okay, and that was the last line that I had of this slide. That's a very good question. That's the difference when you're working in these solutions. That's what I want you to understand. The second thing is only interpretation. It's just getting tails given that. So it's a dependency. Whereas the one that when we flip coins, these are called independent events. They don't matter. It doesn't depend on this. So another dependency problem could be like raining. If today rained, the chance of tomorrow raining is going to change. Because it's not going to be like rain today is 30%, tomorrow's 30%, tomorrow's going to be 30%. It's always different. Because if today rained and tomorrow rained, the chances of the third day raining again is lower. It always changes. So the day on the third day has to depend on the second day, and the second day has to depend on the first day. Yeah, that's what conditional probability is. Whereas when you're rolling a dice, roll it once, roll it twice, roll it 3 times, it doesn't matter. It's always 1 out of 6. Chance of getting a 3 is 1 out of 6. You roll it the second time, still 1 out of 6. That's called independent events. That's 9G. Okay, so 9F is just fixing your understanding between just T as an event or T given H. Okay? Now, just before we finish, I just want you to copy that last line there, which describes what I just described to you. Okay, so what I just drew down here is the branch that we just did. See, instead of doing probability of H times probability of T, is now probability of the first event times the probability of the second event, given that the first one happened. That will tell you the chances of both happening. Okay, so if I relate it to the tree diagram again, remember I said this before? Oops, not this one. I said you can have HT, 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 you would have told me that you multiply these two branches. You would have done probability of H, probability of T. But that's only because T doesn't depend on H. But if T does depend on H, the only thing that changes in this formula is probability of H times probability of T given H. That's pretty much what I'm writing down there. Okay, so down here is pretty much a replica. The only difference is in the interpretation. How I read the question. So this is a dependency problem, not a dependency problem. So independent, dependent. Friday, that's what we'll be doing, 9F. So I want you to work on 9E as part of your last exercise before 9F. Okay, that's the only one you're going to learn. 9F is for the exam. I promise you will be there. 9F, you gotta learn that, 9F. Okay, so we're gonna learn that. That's the difference between the two.